If you want, means what say, instead of means what's the radians, if you want to give it in degrees, that also you can give it. So V equal to Vm sin omega t. Vm is Vrms into root 2 sin omega t. Omega is 2 pi f. You can give degree or radians. You have to be careful here. Okay. So this is a sinusoidal wave. Now, like this is a voltage. I'm just adding probably B equal to, say, example 20. Right? That's could be I mean, what's say a straight line, right? The value is coming down. All right, let's not be equal to, say, example 20 into 1. So this is a sinusoidal wave. Let's see, like C equal to A plus B. Let's take a 33 kV RMU. I guess like I'm understanding that like you have some preliminary knowledge on the solar plants. So if not, like no worries, you have to go through some of the SLDs of the solar plants, etc. I'm just trying to understand, like you know that you have a basic knowledge on like solar plants and its layouts. Like maybe when time permits, we'll go through that as a part of this course as well. So it's an RMU. It's a 3-winding transformer. I mean, what's say I'm trying to draw only one leg. So it means what's assume that it is a string inverters. So it means what's it's an LV switchgear. From an LV switchgear, like it is there are multiple cables which is going and it is connected with an inverter. So I'm trying to take only one solar inverter. And the solar inverter converts the DC to AC, right? And it is injecting 1% of the DC component. Assume that it is injecting 200 amps. Assume that it is injecting 200 amps, out of which 1% DC component is allowed. So means what it's not only injecting 200 amps AC, it is also injecting 2 amps DC current. So what we are going to cover as a part of this course, we are going to cover the solar plants. We are going to cover the Harmonics DC injection flicker, which I thought of probably covering it easily because it's all comes under the power quality this one. And like we will try to have some real-time case studies. And I mean, what say, you have to probably practice it. And then means what say, we will review it so that we will go to the next level. Yeah. And we are also going to completely talk about this voltage right through, that is like LVRT, HVRT, etc. Frequency response. If suddenly the grid frequency is changing from 50 Hertz to 49.5 Hertz, or from 60 Hertz system 60 Hertz to maybe 60.3 Hertz, how the inverters are going to respond, and how means a power plant controller is going to give a command to the each and every individual inverters. That also, I mean, what we are going to see in detail. And of course, detailed models versus how to aggregate. So example, if you are performing this study from the perspective of the entire country, if you are studying the performance of entire country, you cannot model each and every string inverter in probably like 100 megawatt plant or 150 megawatt plant. Then this has to be aggregated. The aggregated equivalent model has to be given so that the transmission system operator or the entire country, those who are probably modeling the entire country, will be able to use this aggregated model.